Right. Good morning, folks. Happy Thursday. All right. So today we are going to be finishing 12.4, which is hyperbola. And then we're going to move on to 12.5, which is a section called rotation of axes. Okay. Now, 12.4, I mean, from the work that I've seen on the quizzes and the questions that I've heard from folks, it seems like the conic sections are actually going pretty well. I think the one weakness for some folks is that area and volume section. So if you haven't checked out my new module on Canvas, that is, there's a tab that says area and volume review. And it's my old notes and videos to all of the area and volume stuff. So if that's something you feel like you need to spend some more time with this weekend, please check out that page on Canvas. It's called Area and Volume Review, okay? Other than that, I think let's go ahead and get started with 12.4. It should be a pretty quick one to finish, and then we'll move on to 12.5, which is going to be a lot of algebra and signs like positive, negative signs, and substitutions. So if you don't normally work with a pencil, if you work with a pen, I would suggest a pencil for today, and lots of paper. So, okay. I'm going to go ahead and share my screen so we can take a look at 12.4. All right. So yesterday, after dealing with ellipses for the first half of class, we talked about hyperbolas for the second half. And we talked about how just like an ellipse, it has two vertices and a center and two foci. But unlike an ellipse, the foci are actually further away from the center than the vertices are. And for the ellipses, we could tell which direction it was longer in by simply looking at the bigger number. But with hyperbolas, it was a little bit different because instead we needed to look at which one was the positive squared term in our equation. And that positive squared term was going to be the one that tells us which direction the parabola or the hyperbolas open in. And so if you had a positive x squared, it was going to look like this, where they're opening side to side. And if you had a positive y squared, it was going to look more like the second one, where they were opening up and down those branches. But either way, we wanted to make sure that we knew that the Pythagorean relation was different. And so we were looking at the focus being on one side all by itself, like that distance to the focus squared all by itself. And that was going to equal the distance to the vertex squared plus the distance to the co-vertex squared. And then finally, we talked about how to write equations for the asymptotes, that we, as long as we knew our center, h comma k, that we could count our rise over run on the graph and put that in for the slope, or we could use b over a, okay? And then we went through two different graphs. So we went through the first one, and then we went through the second graph. And hopefully the second graph, it was a little bit more clear where we got this 2 over 6 from. We were just counting on our graph the rise over run of those asymptotes, okay? All right, so are there any lingering questions from yesterday about hyperbolas before we get started? Okay. Thanks, folks. All right, so for this part of hyperbolas, we're going to be looking at that writing an equation given different pieces of information, okay? And so again, we're going to use a similar strategy that we used for parabolas and ellipses, which is let's draw a picture and then think where all those different pieces come from, okay? Okay, so for example number 3, we have given our information about the foci, and I think I was using pink for the foci, and then the asymptotes are given by this equation, y equals plus or minus x over 3. Now, I might actually, before I get started, make this into plus or minus 1/3 x. And just by rewriting it, it allows me to see the slope better instead of being like, oh, the slope is 3. Like, I know very much the slope is 1/3. So let's get a diagram. Okay. So the first thing I'm going to graph on there is the foci. So I'm going to put one at 0, 10 and one at 0, -10. So I have one here. This is 0, 10, and one here at 0, -10. Now, if I were to estimate where the vertices are, I know that they have to be somewhere like here and here, right? They have to be closer to the center than the foci, okay? Now I know where the center is because it actually states that the center is at the origin, so I can actually fill that in. And let's make those a little bit lower. Okay. Now from here, how do we start to draw these asymptotes?
Start at the origin.
Yeah, I could start at the origin, and let's even split these up so I know that I have one asymptote that's a 1/3 x and the other one is a negative 1/3 x. And so if I draw that from my center, I'm going to go up 1 over 3, up 1 over 3, and I'm going to keep going until I get to a point that is on the same y value as my vertex, okay? Now, you might be like, well, how do you know when to stop if you don't know where the vertex is? And so what we can do is we can call this to be, we can say that this is going to be x, and this y value is just going to be 1/3 x, right? We're using what we know from our asymptote. And similarly, if I went to do the other asymptote, I would start at the center. I will go down 1 to the right 3, down 1 to the right 3, down 1 to the right 3, until I get to where it matches the other vertex. So this would be x, negative 1/3 x. And this allows me to sort of sketch that box so I can see where the corners of the asymptotes go through, okay? And so I know my asymptote, one of them is going to go this way, and I know the other one is going to go this way. And so when we're thinking about figuring out our co-vertex and our vertex, what we're going to do is we're going to do a little bit of substitution. So I know that c² equals a² plus b². And I know that C is 10 because the distance from the center to the focus is 10. So C squared will be 10 squared. And A squared is, in this case, going to be the distance that we move up to get to our vertex. And so that is a y value. So instead of a squared, I can plug in 1/3 x squared. And instead of b squared, b is the horizontal distance I go. That's going to be x squared. And so let's multiply this out. We've got 100 equals 1/9 x squared plus x squared. This is going to give me 900 equals x squared plus 9x squared. So I just multiplied everything by 9 to get rid of that fraction. That gives me 900 equals 10x squared, or that x squared equals 9. No, 90. Okay. And so what that means is the distance to go from the center out horizontally to the covertex is going to be the square root of 90. But in my equation, I know I'm going to square it again, so I'm just going to keep this 90, okay? So y squared over something minus x squared over something equals 1, all right? Now I know that that's y squared because my hyperbolas open up and down, and so this 90 is going to go under the x. Now, if I know that I go 90 up, what I'm saying is 100, no, let's choose a different line. 900 equals 90 plus 9 times 90. Nope. Sorry, folks. When we're looking at that distance, we know that the y value has to be 1/3 of that distance. So if we're looking at x equals the square root of 90, and then what we're looking for is 1/3 of that value is going to be the distance to the vertex, not the covertex. And so we're going to get that distance to be 1/3 of that, and then we're going to square it, which is actually going to give us 10. Okay. The other way you could have thought about this is this number plus this number has to give you 100. So one of the distance to the vertex squared plus the distance to the covertex squared has to equal 100, because that's the distance to the focus squared. And so we get 90 plus 10 gives us that 100, okay? And so now that we filled in our two denominators, we've got our equation for this hyperbola, all right? Pardon my Thursday morning, but I hope that was kind of quick. Any questions about number 3?
How did you get to 10?
So I think the easiest way to think about it is to go back to this equation. Yeah. So you know that c squared is 100.
Got
and
it.
you know that one of the other numbers is 90. And so 90 plus what gives you 100 is going to be 10.
I'll take it.
Okay. All right. Let's take a look at example number 4. Okay, I think example number 4 is going to be a little bit more straightforward, but we're still going to have to do some work to find some of the missing numbers, okay? So we have vertices and we have foci. And so we're going to start, same thing, by drawing a graph, sketching it out so we can see what it is that we're looking for. Now this time my vertices are along the x-axis, so I know there's one at about +3, 0, and -3, 0. And then I know my foci are at +5, 0, and -5, 0. And because the problem told me initially, my center is at the origin. Now, our question is, in order to write our equation, we need to decide, is it x squared first or y squared first? And then we need to figure out what number goes under x squared and what number goes under y squared. So does the x squared come first or does the y squared come first?
The x squared.
X squared, how do we know that?
The vertices are along the x-axis.
Vertices and the foci are along the x-axis, exactly. So I know I can fill in an x squared up here and a y squared after the minus sign. Now, the number under x is going to be the distance from the center to the vertices. And so I know that I went out 3 units from the center, so it's going to be 3, but then I need to square it. So I could write 3 squared, or I could write it as 9. But we don't want to take the 5 and put that underneath the y, right? Because we need to figure out exactly how far up we go and down we go from the center to find our co-vertices. And so to find that, we can use our Pythagorean relation. Okay. And so this is going to give me 5 squared, because that's the distance from the center to the focus, equals 3 squared plus b squared. And this will give me 25 equals 9 plus b squared, 16 equals b squared. And so I can write the denominator of y squared as 4 squared, or 16. Okay, so this version is totally fine. Or you could say x squared over 9 minus y squared over 16 equals 1. Either one is totally fine. Okay. So for a lot of these problems, you're given some of the numbers, but not all of them. And so that Pythagorean relation is really key to helping you figure out what's the other number you need for your equation. Okay. Any questions about number 4?
I do have a question.
Okay. What is your question, my dear?
How can we find the asymptote for number 4?
Oh, okay. I love that question. So if you had the asymptotes, that means that you would have drawn this box, yeah? And you know that your asymptote goes through the center and through the corners. And so let's just stick with that one for a moment. So if I want to find the slope of this line, I can pick any 2 points on there and count my rise over my run. So let's say I start here, 0, 0. And this, what's the coordinate of that point?
3 root 16.
Will it be 3 and 4?
3 and 4, yeah, or root 16, perfect. So this point is 3, 4. And so if I think about counting the slope, I want to find the rise. So from this point to this point, how far up did I go? I went 4. And then the run is 3. So the slope of this line is rise over run. Does that make sense?
Yes.
Okay. If you do the other one, the other asymptote, you could do the same thing. You could say, okay, I'm going to start from here and I'm going to go to this point. So you go down 4 units and you go over 3 units. So your slope for the second asymptote will be negative 4 thirds. Okay.
Thank you.
You're welcome. All right. So we've got one last example here. We've got vertices and we've got the asymptotes. And so let's go ahead and try and sketch that out and see where we get. Oh, we did do applications. Whoops. Okay. All right. So example 5. Let's draw the picture. Let's see what we get. Okay. So I'm just going to start by drawing the vertices here. So I've got 3, 0 and negative 3, 0. And then I'm going to sketch the box that will help me determine my asymptotes and my covertices, okay? Before I do that, I can already set up my equation as something minus something equals 1. And that first fraction is going to have an x squared on the top because my vertices are along the x-axis, and the second one will have a y squared because that's the direction of the covertices. So in sketching the rectangle to help me draw my asymptotes, I don't know exactly what it's going to look like. Like, I don't know how tall to make the rectangle, but let's just kind of sketch one just so we have a diagram to look at, okay? And then let's draw in one of our asymptotes. And so if we zoom in, we want to say that we have 2 points, right? We have our center, and we have this point at the corner. And so I know that to get from the center to the point at the corner, the slope is going to be 2 over 1. I'm going to go up 2 over 1, up 2 over 1. So if I start at 0, 0, what is the next sort of nice point I could draw along this line?
Negative 6 over 3.
Yes, we could definitely do that. Sorry, I think my question was not worded well. I was imagining like the next point along in that positive direction, like towards the corner. So if this is 0, 0, then this point is going to be 1, 2. Does that make sense? Yeah.
Yeah.
And then the next point would be 2, 4. And then finally we get to here and it's 3, 6. Now, how did we know to stop at 3?
Because of the vertex.
Because that's where the vertex is, exactly. We matched this x value with the x value of our vertex. So we need to stop because that's the corner of the box. And so what we've done here is we've determined like that corner, that helps us figure out the number that goes underneath y. So the number underneath x is 3 squared. And we knew that from the beginning because that's where the vertices were. But the number underneath y squared is going to be 6 squared. Because that's how far up we go to get to the corner of the box. Meaning that's the y value of the co-vertex. Okay. So again, you could leave it like this. You could multiply out the numbers. That's fine too. All right. Either version here is fine. All right. Any questions on writing equations from the given information?
I just have a question about when we graph. So like I would like to do the asymptote first because then I have a more visually, it makes sense for the graph. Is if our picture is off one way or another, will it matter as long as the math is right?
No. So like obviously my diagram is terrible. It's not to scale. And I'm sure that bothers some of you guys. And you're like, oh, why won't you just make the rectangle taller? This is fine. Like if your picture's not drawn to scale, but your numbers match what they're supposed to be, that's really fine. Okay. The diagram is meant to be a tool, not like a test of how accurate you can be with your drawing.
All right, awesome.
Okay. All right. Any other questions about writing equations given the information?
Maybe one.
Okay.
When you look at it gives you the vertices and then it gives you the asymptotes. When you scroll up and you look at the equation of the asymptotes, it says b over a.
Yeah.
So right over there you have y is 2 over 1. That's not technically the value. Would that just mean the ratio that if you have one, the other one has to be doubled?
Yeah. So let's actually write that out. So you were saying, okay, like the slope is 2, so it's 2 over 1, but b is not 2 because a is not 1. And yeah, it all becomes a ratio. So 2 over 1 is the reduced form. Kind of like yesterday we had an asymptote that was 2/6 as the slope, but we reduced it to 1/3.
Yeah.
Yeah, it's exactly like that.
Okay, so if let's say that we did get one of them, could we just use that ratio in order to jump to the second one and then just go back and check our work through the Pythagoreans kind of a thing?
Yeah, as long as you make sure to have a multiplier in there, you're fine.
Sounds good.
Mm-hmm. All right, sorry. I had actually written out what you said, but the transmission froze. So yeah, this right here, this 2 over 1 is the reduced form. Sometimes it's the same as the actual asymptote, but sometimes it's not. So we need to make sure that we don't just pull those numbers right from there and make that 0.2 comma 1, but it is the reduced form and you can just multiply however many times to get to the vertex that you have. All right, we've got one last question here. Great question, Patrick. How do coefficients affect the hyperbola? Same thing, they make them either more narrow or they make them wider. So one thing you could do is you could go to Desmos if you like and play around with the graph. So if you put in like x squared over a squared minus y squared over b squared equals 1. If you put that into Desmos as an equation, they'll ask you, do you want to create a slider button? And you're going to say yes. A slider button just means that they'll give you different values for A and B, and you just slide it, and you can see what changes in the graph. That's pretty cool. So if you're a pretty visual learner, you might want to take a look at Desmo. It's much nicer than a graphing calculator in the sense that you can type an equation in any form. You don't have to have like y equals in order for it to graph. Okay. So col is A, the value from the center to the vertices. So let me scroll back up to our formula. Yes, so if you use these formulas, then yes, A will be the distance from the center to the vertex. Okay. They don't change the Pythagorean outcomes. Can you clarify what you mean by that? The Pythagorean relation is just like whatever your distances are, it's helping you find those distances. So as long as you have the distance, it shouldn't matter because the equation already takes into account the coefficient. Okay. I'm not sure if I answered your question, but I hope I have. If you have a specific example, we can definitely take a look at that later. Okay, we've got one last example here for today. Sorry, I've been a little all over the place this week. So I found out last week that I got asked to pick up a second class, which is why I can't stay as long anymore after lecture. But it was like a surprise, like last minute, like Sunday night, hey, can you take over this class for the rest of the summer? So I've been like a little bit frazzled this week. So if you feel that energy, it's not you, it's 100% me. I need to figure out how to manage my schedule a little bit better. All right, but for hyperbolas, we're gonna revisit this idea of tangent lines and normal lines, okay? We're not gonna worry about volume and area for hyperbolas. We'll save that goodness for parabolas and for ellipses, okay? But in this question, we have a conic section, all right? So we have 100x squared minus 9y squared equals 225, okay? Now, I know that this is a hyperbola because of that minus sign. And more specifically, I know that this is a hyperbola that opens side to side because the x squared comes first, okay? So I don't need much more than that to answer the question. I don't even need that to answer the question, but I want us to kind of think about like, what are we doing here? When we're finding these tangent lines, like, what does that look like for us, okay? So let's imagine that we had this hyperbola. I don't know the exact values on it, but that's okay, okay? And I have a given point on my hyperbola. And it's this point, 2 comma 5 root 7 over 3. And I believe that should be like here somewhere, okay? And so part A of the question says, here's the point. We'd like you to find the equation of the tangent line to the curve. That means there's a line that looks like this, and we want to find the equation of that line. And so as soon as we see the words tangent line, I want us to immediately be thinking y minus y1 equals mx minus x1, okay? And if they give you a point, plug that in right away. Get yourself to a place where you have more numbers and then you have space to do the actual calculation. So we can say this is y minus 5 root 7 over 3 equals, let's leave a space for the slope, and then x minus 2, okay? So to find the slope, we need to use derivatives. And like we talked about yesterday, we're going to use implicit differentiation. So we should not solve for y. You can. It shows that you're capable of doing it, but it makes your work so much harder, okay? You don't need to make your work harder for yourself. Go with the easy route, find the derivative using implicit, and that's going to be, so 100x squared is just going to be 200x, right? That part is pretty straightforward. The only thing you need to remember is for the derivative of 9y squared is going to be 18y times dy dx. And the derivative of 225 is 0. Now, let's say for a moment on Tuesday's test, you forget the dy dx. Then your derivative would look like this. There's nothing to solve for. There's no way, like if you forget the dy dx, there's no slope in your equation, which means that's not helping you find the slope that you need, okay? So let's make sure we remember we gotta have that dy dx there so that we have something to solve for. We have something to plug into our tangent line equation. Now from here, let's solve for dy dx. So that's going to be 200x over 18y. And then I'm going to plug in the points that I have. 200 times 2 over 18 times 5 root 7 over 3. And let's take a look at some things that reduce. These reduce to 6. And then I've got 400 over 30 root 7. You could reduce to 100 over 9 too. I don't know why I didn't. That's totally fine. But we can reduce at any stage. And I think here we can reduce this to 215. And so our slope that we put in is going to just be 200 over 15 root 7. And this would be fine enough for an equation of a tangent line. No need to distribute that really gross looking slope to the x and to the -2 and to find a common denominator with the other side. You can just leave it like that. Okay. Any questions about the tangent line here? All right. What's the one thing that we need to change to find the equation of the normal line?
Reciprocal, change sign.
Reciprocal and change the sign, exactly. Sign, negative reciprocal, I love it. Okay, so we've got y minus 5 root 7 over 3 equals a negative 15 over root 7, or 15 root 7 over 200, x minus 2. And as long as you flip your fraction and change the sign, we are good to go, okay? So once you've got that tangent line, the normal line is the line that is perpendicular to that tangent line, okay? All right. So folks, there we have it for hyperbolas, okay? Not as many applications, but I think it's a little bit trickier to graph, so it kind of balances out that way, if you will. Okay, so I'm gonna stop sharing my screen here. And before we go on break, I just wanted to talk a little bit about exam number 2, okay? So exam number 2 is going to be on Tuesday of next week. And so we will not meet for class on Tuesday of next week, okay? So Monday, we will have class. We will finish 12.5, whatever we don't get to today. But my hope is that you have enough of a exposure to 12.5 today that it's not going to be like a super last minute studying and trying to learn it on Monday night before the test. Okay, so that's the goal of today, is to get a pretty good foundation. If you want to work ahead, I know some of you have mentioned you're trying to shift your time management so you can get like a little bit more ahead and not always feel behind. If you look at quiz 6 and 7, by the end of class today, you should actually be able to do quiz 7 as well. Okay, so if you want to get that out of the way so that you don't have to worry about that and the exam next Tuesday, that might not be a bad idea. Okay. Now, the exam will be a similar format as the last exam, meaning that you have a 24-hour window for you to go in and access the exam. And once you have done your work, then you submit that, upload it to Canvas in a single file, and you're good to go, okay? Now, I do want to say this, though. There was definitely cheating on exam 1. And I don't really love that. I feel like I can be flexible about a whole lot of things, but cheating on an exam to me it makes me feel like the work that I'm doing is not worth it. Meaning the lesson preparation, the writing multiple versions of an exam, all of these things to try and give you an experience that is as equal to the classroom as I can give you right now. So I feel like I'm trying to do all of this, and I feel like there are folks out there who really are grateful for that. And I know that we all have to work, so that's why I didn't want to give you like 2 hours to take the test. But I will give you guys one more chance as a class. If there's cheating on exam 2, we will change the structure of the test in ways that I think people will not be happy about, okay? We will go to a much shorter time frame, much shorter than 24 hours. It will be very varied in terms of the questions that folks get asked. And there will be a lot more, you need to show every single step, or I will go to a 0, no credit situation, okay? So I definitely have plans for how we will shift things if we need to. I would rather not go there if we don't have to, okay? So as a class, you have one more chance to show me that you are taking this as seriously as you would an in-class exam, that you are holding yourself accountable to certain standards of student integrity because you all signed and hand wrote that statement of integrity, and then some of you continued to cheat, which makes me feel like I can't really trust you, okay? So you should know who you are if you were in that category. Please don't ruin this for the rest of the class. I think a lot of people get, it's just nice not to have to stress out about taking an exam from an online class in like 2 hours, okay? I would like to continue to offer that to you, but I also want to maintain the integrity of this class. So that's my spiel before we go on break. It is 10:15. We're going to meet back here at 10:25, and then we will pick up with 12.5. Now, if you have access to a printer or a tablet, it might not be a bad thing to just print that out real quick, because again, 12.5 is a lot of writing. So I've tried to space it out on the paper for you, but if you want to write it in a regular notebook, that's also totally fine. Okay, so I'll see you folks back here in 10 minutes.